In all of these techniques, I will use some specific icons to present data. For example, look at these icons here. This is turn of face. In slide 37, you can see some turn of faces icons. These icons give me lots of information about the sense, about the emotions of someone, for example. I can make a relation between these faces and some values. For example, when I try to give the final marks to my student, instead of using uh, digits, I can give them some icons to tell them their marks, their status in the class. So chain of faces or stick figures or something like that can be used to give me a visualization of data. I can use them wherever. Sometimes my data is too large and I couldn't directly talk about these data. It, in this case, it's better for me to use hierarchical partitioning techniques like a tree map, like count trees, InfoCube, dimensional stacking. For example, here, in dimensional stacking, firstly, I create a map of relation between, for example, attribute 1 and attribute 2. Okay, but what is the relation between attribute 1 and, for example, attribute 3, attribute 4? In each pixel of this plot, I can present another hierarchy or another level to present, for example, the relation between attribute 3 and attribute 4. We say they are stacked into each other. They are put on each other. You can go through these levels, going down to this level to find a different relation between attributes. However, this strategy has some limitations. You cannot present data effectively when number of dimensions became large. Dimensional stacking is not a good tool for uh, something more than 9 dimensions. For larger dimensions, for example, someone like this. This is another example of dimensional stacking. Sometimes we can talk about, we can use words in words or words within words. This means that I have a, for example, here, I have a 3D plot, and in a space of this 3D plot, I have another 3D plot inside of the first one. Tree map is another way. For example, here there are different categories, and in each category you can find some subcategories, and in each subcategories still you can find some more subcategories like this. You can see a hierarchy here. Data are grouped in some subcategories, and in each subcategory you can find some more subcategories too. I think this image is not strange for you. Something like this is used for file system in a computer. If you are looking for the file systems of your operating system in your operating system, you can see something like this. Each section shows you a space for a file, for a separated file. No video? Why? Why no video? What about the rest of the class? Have you a similar problem? I think the internet link of Hamid Mohammed has problem. Hamid Mohammed, I think the problem is with your internet link for your device. Okay. Uh, InfoCube is another 3D visualization for showing a hierarchy. Maybe someone use a cone, and if your data is complex, you can find you can use a similar methods. For example, like tree map methods or something like that. If the complex data means that your data is not your data has different types. For example, uh, some part of your data is text, some part of your data is comes from uh, social networks and something like that. So, and for example, some parts of your data is more important than the rest. So you can use different fonts, font size, or color, or something like that to visualize your data. Set of questions so that we can know what to keep. Giving you some questions. Some questions for final exam. You mean giving you some question for final exam? Ah, don't worry about the final exam. As I said before, I will give you in this course, I will give you some assignment. We will use some data mining tools like Veka, MATLAB, or something like that. I will give you. I will assign you 10. You will send me your reports, and finally I will I will ask you a very simple. I will ask you to do a very simple exam. When you are talking about, for example, data visualization, it's not our main problem in data mining course. So just I talk them very fast, talking about data visualization techniques very fast, and I pass them very soon. Okay, I don't consume more times, spending more times for data visualization because it's not too important for me in this course. During the term, when I give you the assignments, the homework, you can see uh, what should you do and what are my questions. Islam, don't worry about the exam, about the final exam. Not Islam, all of you. Don't worry about the exam. When I finish chapter 3, I will assign you the first homework. Then you can find my questions. The final exam is very simple. Just I ask you some questions. Those are general. For example, what is data mining, or what is or say me what is clustering? What are the main methods of clustering, or something like that? My questions in final exam is very general. It's completely general. But in the homework, I will ask you to do and applying data minings on different data sets in homeworks, in assignment. I will ask you to work practically. During the time I will ask you, I will give you. Okay, don't worry. Don't worry. Just be calm. Don't worry. At this time, don't worry. After the end of chapter 3, I will give you the first assignment. You can see my questions at that time. Okay? Not now. After finishing chapter 3. Okay. The last part of this chapter is related to data similarity and dissimilarity measures. Similarity means that finding how two different values of two different objects are alike. I'm looking to find how alike two data objects are. Similarity is a number in the range of 0 to 1. 1 means that two objects are completely similar, and 0 means that two objects are completely dissimilar. They are completely different from each other. For example, black and white, they are completely different. So the similarity between black and white is 0. But the similarity between white and white is 1. The similarity between your status in this class is 1. All of you are MSc student, Master of Science student. So your similarity is 1. Also, we can talk about dissimilarity, measuring how different two data objects are. Dissimilarity is 1 minus similarity. It's reverse. And proximity is something between similarity and dissimilarity. For example, I have a data set, data matrix like this, x112, x1p, and finally xnp. This data set has n rows and p columns. Here, it's a data set. Okay. I'm trying to find dissimilarity matrix. Similarity is 1 minus 2 dissimilarity, or dissimilarity, oh, excuse me. Dissimilarity is 1 minus similarity. Similarity and dissimilarity are vice versa. Okay. So most of times we talk about dissimilarity matrix. Here, you can see dissimilarity matrix is a triangular bottom matrix like this. Why? Because it's reflected in the top side. So we just talk about the bottom side of this matrix, this triangle. And you can see that each data point or each object is similar to itself. As I said, dissimilarity is equal to 1 minus similarity. So for each data object, we can see this similarity value is 0. And for the rest items, for the rest objects, for the rest data points, I should find the distance between two attributes. This distance is related to the difference between those 2 points, those 2 objects, those 2 attributes. So I should prepare a distance matrix for this, presenting an equation or something like that. It depends. Firstly, as I said in the first of this chapter, chapter 2, attributes are nominal or numerical. When we are talking about nominal attributes, I can present a proximity measure like this. Distance between I and j is equal to p minus m divided by p. P is number of matches and m is number of matches and P is number of variables. So dissimilarity means how much of, for example, character by character or something like this. How many of numbers are similar and how many of numbers are not similar? Number of characters, for example, are similar and how many of characters are not similar. This is a direct way to find a proximity measure. Another method is that we can use a large number for binary attributes. We can create a binary attribute and talking about them. 0 means there is no distance. 1 means they are far from each other. Okay. Binary attributes are better cases to talk about proximity measures. Look at this. Object 1 has two values, 0 or 1, and object J has two values, 1 and 0. So we have 4 different cases. Object I is 1 and object J is 1, 2, or I is 1 and J is 0, I is 0, J is 1, and I is 0 and J is 0, 2. 4 cases can be presented like this. And we can sum these columns and rows. Q plus R, S plus T, Q plus S, R plus T, and the total of these values is P. So for a two-dimensional attributes, when I'm talking about distance between two attributes, it means I'm looking for the cases that two attributes are not similar. For example, one is 0 and the other is 1, or one is 1 and the other is 0. So distance between I and J is R plus S, R, I is 1 and J is 0, plus S, I is 0, J is 1, R plus 1, divided by Q plus R plus S plus T, or divided by P. So dissimilarity between I and J is percentage of cases that I and J have not a similar value. Also, in some cases, if our data set is asymmetric, we will talk about asymmetric next times. If our data set is asymmetric, I can reduce the dissimilarity formula in this in something like this. Distance between I and J is R plus S divided by Q plus R plus S. If our binary value is asymmetric. Asymmetric means that the number of cases in an attribute is not unique. Okay, So uh, there is another proximity measure too. We call it Jacquard coefficient. Jacquard coefficient is another proximity measure to find similarity or dissimilarity between two items. Jacquard measure is defined in this way. Similar. This is similarity, not dissimilarity. Jacquard is something like this. In this case, you can see that similarity between in Jacquard is Q divided by Q plus R plus S. Q divided by Q plus R plus S. Give an example in the next slide. Just let me define the equations. So similarity of Jacquard is this Q divided by Q plus R plus S. Q is the case that object I is 1 and object J is 1, 2. Both of objects are 1 divided by Q plus R plus S. Here in Jacquard coefficient, still we talk about asymmetric binary. If our variables binary, we should say that Q plus T divided by Q plus R plus S plus T. Or 1 minus Dioj. If, one more time, if my binary variable is symmetric, binary variables are symmetric, then I can say the similarity measure of Jacquard is 1 minus d I of I and j, di of I and j. Okay. Jacquard coefficient is very interesting. It works for both symmetric and asymmetric variables. And look at this equation. Jacquard coefficient is same as coherence. Coherence between I and j is superior of I and j divided by superior of I plus superior of j minus superior of I and j, or q divided by q plus r plus q plus s minus q, or this one. So similarity of Jacquard is equal to coherence between I and j. Let me give an example here. We have a data set here with 3 objects, data from Jack, Mary, and Jim. There are 3 patients. Jack is male. He has fever. He has not cough, and his test 1 is positive, test 2 negative, test 3 negative, test 4 negative. We have 2 more records for Mary and Jim. Okay. As I see here, my data set is not symmetric. I have 2 male and 1 female record here. So my data set for gender, for example, is not symmetric. Oh, excuse me. This one is symmetric, but the rest are not symmetric. For gender, the patient can be male or female. It's not important. But for the test, we can see, for example, for test 4 or test 2, all of tests are negative. But for gender, yes, the patient can be a male or a female. Okay, I'm trying to find a similarity between Jack and Mary, or Jack and Jim, or Mary and Jim. I'm trying to talk about this. So, firstly, I'm removing the case gender here, and just I'm talking about the rest of these items: favor, cough, test 1 to 4. Okay, here for yes or y, I'm putting 1 for P1. For N, I'm putting 0. Okay, I'm replacing in this table, I'm replacing Y or P with 1 and N, replacing N with 0. Okay. For example, when I'm talking about Jack and Mary, I can see that both of them have fever. Both of them have not cough. Test 1 for both of them is positive. Test 2 is negative. Test 4 is negative. And test 3 is negative for Jack and positive for Mari. So when I'm talking about dissimilarity, look at this. D means dissimilarity. Jacquard was similarity. Jacquard is a similarity measure. Now I'm talking about dissimilarity. If I'm talking about dissimilarity between Jack and Mari, I can find right just one items in test 3. They are different. So there is one difference between Jack and Mari, and totally in favor in test 1 and in test 3. We have 3 1 1 for favor, 1 for test, and 1 for test 1, and 1 for test 3. So in the denominator, I will put 3. 1 divided by 3 is 0.33. For Jim and Jack, Jim and Jack are different in cough in test 1, in cough and test 1. Okay, so here we say in 2 cases, both of them are positive. Both of them are 1. In 2 cases, in test 1 and fever. Both of them are yes. Okay. 2 shows this in favor, and in test 1 both of them are 1, are positive, or are yes. Look at this. It's here. Q means both objects are 1. R means the first object is 1 and the second is 0. S means the first object is 0 and the second object is 1. Here, for fever, both of them are 1. For test 1, both of them are 1. For test 3, one of them is 1 and the other is 0. Here, 2 plus 0 plus 1. For Jack and Jim, for fever, both of them are 1 or yes. For cough, one of them. For test 1, one of them. And for test 2, 3, and 4, both of them are negative. So in the equation, I'm writing 1 plus 1 plus 1. It's better if I here, if I replace with zero, 0, this is 1. One, 0. Zero, 0, 0. First, I replace all cases with 0 and 1. Then I'm replacing values and using the similarity formula in the past slide. Okay, just firstly I replace positive or yes with 1 and negative with 0. Now I can compare them easily. For example, for test 2, all of items are 0. So in the last slide, I can see that if object I is 0 and object J is 0 too, we can omit them, because here fever, cough, test 1 to test 4, these 6 attributes are asymmetric. What does it mean? It means that number of positive is lower than number of negative in these cases. If number of positive is not equal to number of negative, or number of 1 or chance of 1 is not equal to chance of 0. For example, gender or sex is a symmetric attribute. It means that if I choose someone, he or she can be. With 50%, the selected human is a man. With 50% is a human, is a woman. The chance of selecting a man or a woman is 50-50. So we say gender is a symmetric attribute. But when we are talking about the result of health tests, the result is not symmetric. It's asymmetric. It means that in most of cases, the tests are negative. Tests are negative. For example, if you look in the society, you can see that most of the people around you have not COVID-19. 99% of people have have not COVID-19. Okay, just maybe 1% of people have COVID-19 or coronavirus. In this case, we say that this attribute is asymmetric. It's not 50-50. It's 1 against 99 or something like that. The result is skewed to one side. So simply replace 1 and 0. I recommend this example for you. Just replace 1 and 0 like me. What I do. Then use these tables here and this similarity here. No, not this one, excuse me. Use this object, this table here, and this one, because my attribute is asymmetric. My attribute is asymmetric, so use this equation for this similarity. Maybe someone decided to use Jaccard coefficient, this one, similarity between people. It's not important because similarity between I and J is 1 minus dissimilarity between I and J. Similarity and dissimilarity are correlated. Similarity is equal to 1 minus dissimilarity, or dissimilarity is equal to 1 minus similarity. Okay, here, as I can see Jim and Mari are between these pairs, between Jack and Mari, Jack and Jim, and Jim and Mari. Jim and Mari has the highest value of dissimilarity. It means their conditions are far from each other. And Jack and Marie has the lowest dissimilarity. So it means the situation and conditions of Jack and Marie are similar together. Not completely similar, but they are comparable. But Jim and Marie are far from each other. Their conditions are far from each other. Okay, that is enough for today. That is enough for today.